Assalamualaikum warahmatullahi wabarakatuh and good evening. My name is Muhammad Dani Lukman bin Nur Hizam, AA241095 from Section 6. Today I would like to present my CLO3 presentation, which is the title is Chemistry in Plastic Industry. So, this is my poster for chemistry in plastic industry. In these posters, we will discuss about the plastics itself. So, let's go to definition of the plastics. Plastics are a wide range of synthetic or semi-synthetic materials that use polymers as a main ingredient. Their plasticity makes it possible for plastics to be molded, extruded, or pressed into solid objects of various shapes. So it means these plastics can be produced as a product with any industrial process. So this adaptability combined with a wide range of other properties such as being lightweight, durable, flexible, non-toxic, and inexpensive to produce has led to their widespread use around the world. As we know, nowadays we use plastics everywhere in this world. Most plastics are derived from natural gas and petroleum, and a small fraction from renewable materials. Next, we will go to the second point in this poster, which is the types of plastic. So as we know, there is three types of plastic. The first one is the thermosets, and then the second one is the thermoplastic, and then the last one is elastomer. Let's go one by one the types of plastic. So the first one is the thermosets. Thermosets plastic is a rigid plastic that is permanently hardened after being heated or exposed to radiation. Once cured, thermosetting plastic cannot be melted or reshaped. It means that after we heat the thermoset plastic, we cannot change or reshape the shape of the plastic. So there is some of characteristic of this plastic, such as the high heat resistance, chemical resistant, durable, dimensional stable, and brittleness. So we also have some example of this thermoset plastic, such as polyurethane, or we call it as PU, bakelite, vinyl ester, and Duroplast. Next, we will move to the second type of plastic, which is the thermoplastic. Thermoplastic is any plastic polymer material that becomes pliable or moldable at a certain elevated temperature and solidifies upon cooling. So the difference between thermosets and thermoplastic, the thermoplastic still can be changed the shape although getting heat or exposed to radiation. Meanwhile, thermosets cannot be changed or reshaped the shape of the plastic. So we have some characteristic of the thermoplastic, such as the high temperature resistance, chemical resistance, durable, lightweight, and impact resistance. So we have some example of the thermoplastic, such as acrylonitrile butadiene styrene or ABS, nylon, polyethylene or PE, and polypropylene or PP. So the third and the last type of plastic is the elastomer. Although we always heard elastomer is from the rubber, but actually plastic also have the elastomer plastic. So elastomer plastic is a type of flexible plastic material that can deform when heated but returns to its original shape. So we also have some characteristic here, such as elasticity, chemical resistance, lightweight, weathering resistance, and processability. For the weathering resistance, it means it can hold in the high level of UV light, and processability, it means we can process it easily. So we also have some example here, such as thermoplastic elastomer or TPE, which is the combination of thermoplastic and elastomer plastic. And then the last one is styrene butadiene styrene or SBS. So let's move to the next poster. So for the second poster, we will discuss about chemical bonding of plastics, and then the second one is electronic structure of plastic atom, and then the third one is thermochemical conversion of plastic into jet fuel hydrocarbons, and then the last one is applications of plastic in this world. So let's see about the chemical bonding of plastics. So first, as we know, most of the plastic bonding example in the literature are examples of covalent bond formation. So polymers are held together by primary bonds, which is the covalent bonds, and secondary bonds, which is the van der Waals and hydrogen bonds. So polymers also are giant molecules that consist of long chains of units called monomers. So as we can see here, we have some types of bonds for the chemical bonding of plastic, which is the first one is ester bonds, and then the second one is the carbon bonds, and then the third one is urethane and ether bonds. So all of these bonds are the example of covalent bond formation, since the plastics bonding is like the carbon bonding actually. So the second one is the electronic structure of plastic atom. So for this part, the electronic structure of a plastic atom is essentially based on the carbon atom, as most plastic are primarily composed of long chains of carbon atoms with hydrogen atoms attached. The primary building block of most plastic is carbon, which has 6 electrons with the configuration 1s2, 2s2, and 2p2. This will form many covalent bonds with hydrogen atoms, creating a repeating pattern within the polymer chain that constitute the plastic material. So actually, the chemical bonding of plastics and electronic structure of plastic atom have the connection, since like before, chemical bonding say that the most of the plastic bondings are covalent bond formation. So there is a relation with the electronic structure of plastic atom, which is with the electronic structure of plastic atom. It also said this will form many covalent bonds with hydrogen atoms, creating a repeating pattern within the polymer chain that constitute the plastic material. So the third one in this poster is about thermochemical conversion of plastic into jet fuel hydrocarbons. So as we know, we always consume more and more plastic in this world, and that will produce more and more plastic wastage. So with this process, this plastic wastage can be reduced and then turn it to the jet fuel hydrocarbon. So in this side, as we can see here, there is some process that we can do to change it to the jet fuel hydrocarbons. So in there is 6 process actually to turn it from the plastic to jet fuels. As we know, most of the process need to burn the plastic wastage. So the difference between all this process is the way how to burn the plastic wastage. So the first step or the first way to burn it with the microwave assisted degradation, followed by hydrotreatment, and then the second one is the catalytic pyrolysis. The third one is non-catalytic pyrolysis, which is have the 2 ways to do it, and then the third one is the hydroliquefaction, and then the last one is alcoholysis followed by hydrogenation. So let's move to the last point, which is the applications of the plastic. As we know, we have consumed more and more plastics in our daily life. So we use the plastic for the packaging, kitchen utensils, piping systems, textiles, toys, and automotive. So as we know, for the packaging, we used to pack our food or our belongings using the plastic. And then our kitchen utensils such as the knife, the spoon, and then the fork also being made from the plastic. And then for the piping system, as we know, we use the PVC for the material of the pipe. So we also use the plastic for the toys, and then the automotive, which is the car parts. So for the conclusion of this presentation is the plastics is the one of the main component and material for the industry in this world. So that's all from me. Thank you.